With trial and improvement questions, the important part is you're working out. You've got to show a systematic method of finding the solution to an equation. So what we've got here is a question that says, show that the solution to the equation x cubed plus 4x equals 12 lies between x equals 1 and x equals 2. And then once you've shown that, you've got to find the solution to one decimal place. This is quite a common question really, so you've got two parts of it. Don't forget to answer the first question, the first part. So it's important to show something, so when you're asked to show something you actually have to do the working out. So I'll use a table to do mine, so I'm going to have my value of x on the left hand column of my table, and then I'm going to substitute in that value and work out the solution to x cubed plus 4x in the second column. So I'm going to show that when x equals 1, substitute that in, so when 1 cubed is 1, 4 times 1 is 4, so when x equals 1, this equation equals 5. Now, the question says show that the equation equals 12, so I want it to equal 12, so when it equals 5, it's clearly too low. So I'll write that next to my equation. Then I'll substitute in x equals 2, so 2 2s are 4, 2 4s are 8, plus 4 2s are 8, equals 16. So it equals 16, I want it to equal 12, so clearly the answer is too high. So what I'm showing here now is on my exam paper, when I'm answering a question, I want to either write a sentence underneath here or to the side, depending on where you're working. So I'm going to take that information and say the solution must lie between x equals 1 and x equals 2. So I'm showing the examiner that I understand what I've done, and I'm highlighting the equation that I've worked out to show that answer. Then it says show that the solution to one decimal place. So if I know that 1 is too high, 1 is too low and 2 is too high, then I have to go in between. So I'm just going to rule off here, but then continue my table. So I think I'll go in the middle of those two, so I'll go 1.5 next. So if x equals 1.5, then substitute in this value here, and the answer will be 9.375. So when I know the answer is 9.375, I know that the answer is still too low. So it's 1.5 is too low, 2 is too high, so I'm still going to go higher than that, so I'm going to go 1.7 this time. So if I substitute in x equals 1.7, this time my answer is going to be 11.713. So again, this time the answer is too low. So I've done 1.5, 1.7, so I'm going to go up again, so I'm going to go to 1.8. So I'll substitute in the value of 1.8, then the answer is 13.032. So this time I've got a value that's too high. So that's good. I now know that 1.8 is too high and 1.7 is too low. So I can highlight the fact that the answer, the solution, must lie between x equals 1.7 and x equals 1.8. So the last thing to decide is the answer nearer to 1.7 or is it nearer to 1.8? Because my answer is going to be either 1.7 or 1.8, I'm not sure which yet. So I've got to go in between these two values. So I'll just rule off again just so I can see my working out. And I'm going to go 1.75. So I'm going to go halfway between these two values. So I'll substitute in x equals 1.75 and I will get the answer is 12.359. So once I substitute that in, I know that that is too high. So 1.7 1.75 is too high, which means the value must lie between 1.7 and 1.75. So if the solution lies between 1.7 and 1.75, to one decimal place, to 1 dp, x must equal 1.7, because no matter what the value is, it will round to 1.7. So with our second example, another equation, this time x cubed minus 3x equals 6, and we're going to show that the answer lies between 2 and 3, and then find the solution to one decimal place. So we're going to approach this in exactly the same way as we did with the last example. So I'm going to start with a table. I think a table just makes your working out nice and clear. So again, I'm going to have my values of x. I'm going to find out the solution to the equation x cubed minus 3x. Hopefully the whole thing will equal 6, and we'll find out as we go. So if I substitute in x equals 2, so here 2 2s are 4, 2 4s are 8, minus 3 times 2 is 6. So the answer to this is 2, so that's too low. So then we substitute in x equals 3, so 3 3s are 9, 3 9s are 27. Take away 3 3s are 9, so the answer is 18, so it's far too big. So I can show here, just rule off. So I can show that the answer must lie between these two. So the answer must lie between x equals 2 and x equals 3. So that's the first part of the question done, and I've been very clear showing my working out. So for the second part of the question, I need to find the solution to one decimal place. So we've done 2 and we've done 3, so let's go halfway between. Let's go x equals 2.5. So when x equals 2.5, I substitute those values in, I get the answer will be 8.125. So this answer here is too large, isn't it? It's still too big. So I need to come down. We can do 2.4. We'll come down to 2.3, I think. So if x equals 2.3, if we substituted in 2.3, we cubed it, and then we took away 3 lots of x, and our answer would be 5.267. So now I've come down too low. So we'll go in between those. We will do 2.4. So let's substitute in x equals 2.4, and then the answer will be 6.624. So now my value is too high again. So I can show that the solution must lie between, x equals 2.3 and 2.4. So all I need to do now is go in between those two figures to find out whether or not it's nearer to 2.3 or nearer to 2.4, because I only have to give my answer to one decimal place. So I will have to try x equals 2.35, so halfway between these numbers. And when I substitute that in, I get the answer is 5.927 and some other numbers. So 5.927 is too low. So then I know that the solution must lie between 2.35 and 2.4. So this example shows the opposite answer as the last example we did there. So if it's between 2.35 and 2.4, then no matter what the solution is, it could be 2.36 or 2.37 or 2.38, whatever the answer is going to be, I would round it to one decimal place, to 1dp, the answer must be 2.4. So we're rounding up this time. Whereas in the last example, we rounded down. So it's really critical. This last step is always critical. If they ask you to find the solution to one decimal place, you have to do the 2 decimal places halfway in between the 2.3 and the 2.4 to find out if it's nearer to one answer or the other. So then you can confidently give your answer. And you must show that in your working out. You can't just either work it out and not show the examiner or guess. You really need to show that you're going halfway between those two values to show that you definitely know the answer is 2.4.